Good afternoon, everyone. My name is Shravan Kumar from Delsoft Technologies, New Delhi. Welcome all to this 3 days online faculty development program on networking simulation using Netsim Software, organized by Delsoft. So Delsoft is a software solution provider in education sector where we provide software solution to different departments like electronics communication, electrical, computer science, IT, mechanical, and civil engineering. So we conduct these kind of online sessions to make aware of latest technologies and related software to faculties and researchers. So in continuation of this, we have organized this 3 days online FDP program on networking simulation using Netsim software. So first we will have an introduction of Netsim software, then we will design and analyze one inter-network scenario, then we will go to the custom code environment and see how we can implement the custom code in Netsim. So during this session your mics will be muted, you can ask your question in question box. So we'll discuss after the presentation. So this is Netsim version 9.1 network simulation and emulation platform. So first question here is why we require this kind of simulator or Netsim. So on this slide we can see there are some observation in networking domain. So where we can see that our existing network traffic will becomes 4 times this year as per our use of mobiles, tablets and other handheld devices that are adding to this network cloud. So we watched 2+ billion videos every day, which also constitutes heavy traffic on network. Further, more and more devices like mobiles and handheld devices are joining this network, forming a network of things network. So on having these observation, which leads researchers in the field to conduct research on this domain, which are mobile ad hoc networks, wireless sensor network, cognitive radio network, LT long-term evolution and long-term advanced network, and Internet of Things IoT. And also 50% of all research papers in IEEE and ACM refer a network simulator. So that's why we require this kind of network simulator in our research. So this is an overview of Netsim. Netsim is a scientific tool for designing and validating networks and protocols. Hence, it has a lot of relevance in protocol research and development. And in defense also, it is used for simulating network-centric warfares. So it has a wide range of technologies which is possible to simulate in Netsim are internetworks, which is LAN, WAN, mobile ad hoc network, WiMAX, cellular network, cognitive radio, LTE, and wireless sensor network, which includes ZigBee. So in Netsim we have 2 versions. One is academic and one is research. That is standard version. So in academic version you can design and analyze all your technologies with GUI. But in standard version, users are provided with C source code of network protocols which are implemented based on IEEE and IETF standards. The purpose of the user source code is to enable users to edit the standard protocol code according to their own implementation. Then further they can link it with Netsim and analyze the performance of the newly designed protocol. Now what's new in Netsim 9.1? So this latest version of Netsim is 9.1, which is launched earlier. So some new features has been added to the existing version. So these are LTE advanced feature has been added with carrier aggregation and multi-antenna techniques, such as SU MIMO and NU MIMO. Then some relay nodes has been added. In MATLAB interfacing, new application of creating and simulating real-world communication parameters and dynamic clustering in low-power wireless sensor network has been added to enhance the functioning of cluster heads in wireless sensor network scenario. In wireless network, a very popular and effective rate adaptation algorithm, Minstrel, has been added for an effective wireless communication in the network. And in packet animation, a detailed packet information has been added along with running the animation that we can see in the simulation part. Then a new technology called Vannet or vehicular ad hoc network has been added that can be simulated using a third-party software called Sumo, that is simulation of urban mobility. Now Netsim customer segments. So Netsim has a huge number of customers varying from industries where it is used for network design and network validation, in defense labs where it is used for network-centric warfare simulation, then in R&D labs it is used for protocol development and new technology testing. Many PhD research papers are published by utilizing this tool. So Netsim has an academic version which is to be used in network labs of undergraduate curriculum and advanced network lab of graduate courses in electronics, computer science and other related domains. So we can use it in our curriculum and in the research labs also. This is the internal architecture of Netsim, where users will design the network and configure it in a GUI interface, which will be further simulated by Netsim engine and thereby provide multiple metrics regarding performance of the simulated networks. So users are not required to write any script or code while designing and configuring the network scenario. So as you can see, it is utilizing a virtual network stack which actually mimics the real world TCP IP stack and hence makes it very easy for any user to edit protocols and also get fairly accurate results. Furthermore, user can also perform research on cross-layer protocols like Leech. Now Netsim technology metrics. So Netsim is divided into modules or components. So in standard versions, user can make a selective choice while using Netsim. So this is a list of the content of each component and the corresponding IEEE and IETF standards referred during implementation. So for illustration, component 1 consists of protocols implemented in WAN, LAN, wireless LAN like Ethernet, IEEE 802.11, ABGN, ACNP, and component 1 is the base component. That is, all other components require component 1 to run. Similarly, component 2 consists of network based on legacy technologies. Component 3 consists of BGP network. Component 4 contains mobile ad hoc network and Vannet, vehicular ad hoc network, and WiMesh technologies. Then cellular technologies like GSM and CDMA in component 5. The same way, component 6 contains wireless sensor network, IoT, Internet of Things, and ZigBee. Then cognitive radio network is wireless radio network, and LTE, long-term advanced evolution and advanced network. So this is modeling and simulation, where a scenario is created. So user systems having less memory may face issue while creating large network scenario in GUI. So for this purpose, we allow the user to write the scenario in XML file. So this is suggested only for advanced users, and Netsim support team usually assists the users when writing such a scenario. Okay, so we can simply drag and drop our devices into the environment. We connect it through the wired provided, either it is wired or wireless. For properties, we can just right click on the devices or links, we can set the properties, and we can run it. Now, Netsim provide distinct quantitative metrics at various abstraction levels such as network metrics, application metrics, link metrics, protocol metrics, and device metrics. So with the help of metrics, users can analyze the behavior of the modeled network and can compare the impact of different algorithms on end-to-end behavior. So in network metrics, it allows user to view the values of the metrics obtained based on the overall network. Then in application metrics, it displays the various metrics based on the application running in the network scenario, like throughput, delay, and many more. The link matrix displays the values of the metrics related to each link, like packet transmitted, packet errored, packet collided, and many more. Then protocol metrics, it displays the protocol based metrics which are implemented in network scenario. Metrics will vary depending upon the type of network simulated. In this case, you can notice TCP metrics, IP metrics, OSPF metrics. So in device metrics, it displays the device related metrics like ARP table, IP forwarding table, etc. Then in second part, we can see the packet animation, which enables user to watch traffic flow through the network for in-depth visualization and analysis. So unlike other network simulators, which only shows the transmission of packet, Netsim goes a step further and displays some basic packet information like packet ID, type of packet, and whether it is successfully transmitted or not. User can also observe the changing location of nodes in wireless communication due to inherent mobility. Now, Netsim allows users to generate trace files which provide detailed packet information useful for performance validation, statistical analysis, and custom code debugging. So, first is packet trace. So, packet trace logs a set of chosen parameter for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, errors, collision, etc. Then, as we know, Netsim is a discrete event simulator, so it creates event trace. So in event trace, it records every single event along with associated information such as timestamp, event ID, event type, and some more in a text file or .csv file, which can be stored at a user-defined location. Then we can have dynamic metrics where it allows user to monitor the value of a parameter over simulation time. So this is essential for researchers to understand the behavior of a network at any instant of simulation time. So here we can see the link throughput, application throughput, and TCP congestion graph that can be plotted dynamically, and these plots can be done offline or during the simulation. So we usually prefer after the simulation because during the simulation it slows down the speed of the simulation. So this is a very important slide because many people usually ask how this software is different from open source software available freely on net like NS2 or NS3. So on this slide we have tried to answer this question which is asked by many people. So as we know, we have to write a lot of programming while using any open source tool for creating and simulating our network design. So for creating a simple design, we have to write a lot of program. So in the first part of the graph, you can see there is an equal load of understanding the language and the simulator, and then user algorithm. So users spend 80% of their time understanding the simulator and its language. So rather than understanding the user algorithm, they emphasize more on language and simulator. So considering these difficulties, Netsim has been designed with its GUI feature along with custom code editing, where we can design and analyze our network in GUI, and if we wish to change existing protocol or create our new protocol, that can be done using Microsoft Visual Studio 2010, where we can save our files in all extension, a DLL extension, and link it with Netsim GUI. So this Netsim understands the DLL extension file. So anything we want to edit or create our own protocol, that has to be saved in a DLL extension. So we have to just save the DLL extension and copy that DLL file into the bin folder. Then we can access those DLL files, and we can access our DLL extension file and the protocol. So that I will show you in custom code implementation how we can do this. Now these are some new features that have been added in Netsim. So this is Vannet, Vehicular Ad Hoc Network. So Vannet is a part of Mannet, Mobile Ad Hoc Network, where Mannet is an infrastructure-less network which doesn't require additional devices such as routers, switches, access point, base stations. Since it is a self-configuring network, the devices themselves work as a router. So Vannet here can be of two types. First is V2V and V2I, vehicular to vehicular and vehicular to infrastructure. So it works on basic principle of LAN, LTE and WiMAX using 802.11 IEEE standards. And Vannet has two components mainly. One is OBU, onboard unit, and second is RSU, roadside unit. So OBU are the device installed inside the vehicle to communicate with other vehicles. And roadside unit are installed at road junctions, and these are stationary in nature, and OBU are mobile in nature. So they provide information and internet connectivity to vehicles commuting on roads. So this Vannet simulation can be done using a third-party software called Sumo. So we can interface the Sumo with Netsim. Where Sumo is a simulation of urban mobility. It's a free and open source tool, vehicular simulation tool, which can be further developed and edited with the help of APIs provided to connect with other tools. So these are research and development done using Sumo, which includes, you can see in the PPT, online loop with the network simulator, performance of traffic lights, eco-aware routing, autonomous route choice, traffic surveillance. These are the research that has been done using Sumo. Now how we can interface with Netsim and Sumo? For that we need a Sumo configuration file which has some sub files inside it. That is edge file, node file, network file, and vehicular routes having information as their name suggests. With the help of this mobility, we can interface it with Netsim, which further simulate the network scenario of Vannet and generate various output parameters such as performance metrics, packet animation, packet trace, event trace, Wireshark capture, etc. So this is how we can interface Sumo with Netsim. So now Wireshark interfacing. So Wireshark, as we know, is a free and open source packet analyzer. It is used for network troubleshooting, analysis, software and communication protocol development. In Netsim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packets and transmit it within the simulated network. Hence, Wireshark can be used inside Netsim to capture these packets at multiple node locations and perform further analysis. Now, Netsim interfacing with MATLAB. So, Netsim has interface with MATLAB software, where we can use some functions given in it related to network technologies by calling those functions in programming using Visual Studio. So, when we save those DLL and link it with Netsim, we can use MATLAB functionalities. This is an add-on module of Netsim that is called Netsim Emulator. Uh, it enables you to run live application in real time with various network conditions like error, delay, and loss. So in the screenshot, we can understand a scenario where we have created an emulated network where we are sending a video traffic from real emulation PC client to other client, where we can see in the output we are getting our video with some distortion, that is due to delay and losses we face in the network during packet transfer. So these kind of real application can be used to analyze in emulation module. So it has application that can be used for network design and validation of military radios, SCADA, metro rails, and for performance testing of newly application and protocols. So it has benefits. It can emulate a wide range of technologies like switching, routing, Mannets, cognitive radio network, 4G LTE, Zigbee networks, and it is cost-effective alternative to hardware emulators as it purely virtual, so it can be used to analyze without any complicated configuration that require in hardware emulators. Now, in order to reduce time and effort of protocol developers, Netsim provides APIs which can be reused to perform activities like packet creation, deletion, IP address comparison, and many more. We also provide a manual in the help section to assist developers while writing or editing the source code. So now I'm done with my presentation. Now we can go to the software where we can see how we can work on this software. These are the research areas that can be used in Netsim. And these are some of the customers we have, over 300 plus customers across 15 countries. So this is the software environment. First we open, this window will come. So if you want to design anything in Netsim, we have to first go to the simulation and new. Here we can see all the components that are provided in Netsim is given here. Internetworks, legacy network, advanced wireless network having Mannet, Vannet and WiMAX, BGP network, cellular network having GSM and CDMA, wireless sensor network, IoT Internet of Things, Zigbee, cognitive radio and LTE networks. So whichever network you want, you just have to click on the network and you can design your and analyze this network. So we just select the internetworks and we will see an environment where we can drag and drop our devices and design our network. So we can see some devices are enabled here to design your network and some devices are disabled. Just we have selected the internetwork, so device related to internetworks would be there and device related to other technologies would be disabled. In node also there are two devices enabled, wired and wireless, and other devices are disabled. So let's say we are dropping two devices, two wired node devices, and two here. Then we connect it through a switch. Then we further connect it through a router. Now we can say this is network A, network B. They are communicating with these network. Again, we can connect an access point to get a wireless network. Let's say we are connecting to wireless devices, and now we connect it through a link. This is wired link. So we have connected the wired link to these wired devices. Now we can connect these wireless devices by having the wireless link. So we have connected this network. Now we can see the device information, the properties of the devices by just right clicking on the device and connect it. Click on the properties where we can see the global properties where we are having a device name, device type, its location. Wireshark can be enabled on any node. So if you enabled Wireshark here, let's say click on online on this device, first device. So the Wireshark would be enabled on this first node, and when we simulate our network, the Wireshark would start and capture the packets. So application layer is outside defined, so we click on transport layer. Where we are having TCP and UDP protocols and other devices of MSS, congestion control algorithm, window size. So all these property dialog box have information of different parameters. So if you want to study these parameters, we can click on the information tab. These are the I tabs given here. When we click on any of the information tabs, maximum segment size, MSS, its definition details would be there, and you can see its range also, how much range we can give this parameter. Okay, so any of the I tab we can select and study. Then network layer is there, and interface Ethernet. So we have three layers: network layer, data link layer, and physical layer. So in network layer we are having IP address, subnet mask, and default gateway. ARP, retry interval, retry limit, data link layer, and physical layer parameters are there. So some default properties are given there just to simulate our network, and we can change this parameter also according to our requirement. So we just select accept and go to the other properties of switch. These are also having the device properties, location. Then we are having three interfaces as the switch is connected to three devices. So we are having three interfaces, two for these two wireless node, wired node, and this is for router. So we can see the three interfaces. One is for wired node A, two is for wired node B. 3 is for a router. So this data link layer having the switch specific properties like switch latency, switch priority, switch ID, switching mode, whether it is store and forward, cut through, fragment free, then speed, STP cost, and physical layer parameters. So these are some default parameters given here. We can change it according to our requirement. So we can change it for other interfaces also. So we just accept it, and we can see the router properties also. So this device name, same properties. We can also enable the Wireshark here. Then transport layer, we have the TCP UDP. Network layer, we have IPv4 protocol. And firewall status, we can enable the firewall. So if we enable the firewall and we set any device on this firewall location, so that device will be blocked for having the packets. It will not get any packet from the router. So we can set the firewall status from here. These are also having 3 interfaces for 3 different devices. Switch, access point. Okay. So this is also having scheduling type, buffer sizing, default gateway, IP addresses. All these properties are given there. So we can click on accept. Also we can go to the access point properties. Here also we can enable the Wireshark. These properties are common. We have 2 interfaces, one is wireless and one is Ethernet. In wireless interface, we can see the data link layer, physical layer parameters. Okay. So we are having the IEEE 02.11e rate adaptation algorithm we can select, and retry limit, RTS threshold, standards we have ABGN, ACNP. Then we have standard channels, okay, and ED threshold, bandwidth, frequency band, transmitting power. All this information we can select. Okay, then this Ethernet interface, you can click OK. Also we can go for the wireless properties. So in all these properties are common. So in interface wireless we can select the network layer properties of IP addresses, subnet mask, then data link layer properties are there. There also we can set the rate adaptation algorithm, standards we can select. Okay, so all these properties we can select. Apart from the device properties, we can select the link properties also. So in the wire link, we are having uplink speed, downlink speed, BER rate, downlink BER rate, propagation delay, downlink propagation delay. Okay, so these we can change or we can accept it for default. Also, we can have the wireless link properties where channel characteristic is there. In channel characteristic, we are having 4 types of characteristics. So here we can select the no path loss for this one. So after setting these parameters, now we can select that we are sending some application on this network. So for that we have to drop down this application tab and right click the properties, and here we can see we can send the various kind of application on any node like CBR, custom, email, HTTP, video, voice, database, FTP. All these application we can send on any node, from any node to any node. Means if you select a custom type of application from node 1 to node 9, node 1 to node 9, and this is your packet size and inter-arrival timing. In packet size, you can select the distribution of the packets. Either it can be constant or exponential, or you can define the values also. And inter-arrival time, you can see the distribution of arrival distribution of packets. Then value of timing, inter-arrival timing we can define. Okay, so we have added one application from 1 to 9. Again, if you want to select, let's say from 2 to 6 or 2 to 4, so we can add one more application where we can send a CBR application from 2 to 4, same values. So now we are sending two applications from 1 to 9 and 2 to 4, custom application and CBR application. So we can now simulate our network, but before that we can add some more properties here that we have seen in the presentation, that we can add packet trace, event trace and dynamic matrix. So here we can select the packet trace. So these are the attributes of packet trace that we can add in our trace file. Okay, so to select that file, and event trace also, these are the attributes for events. Click on OK, and this is for dynamic matrix. We plot graph after simulation. This is for link matrix, application matrix and congestion window matrix. So we click on OK, and now we run our simulation. Here we set the timing of simulation. Then packet animation is there. We can record animation. We can play and record both at a time, and we don't play or don't record any animation. That will run fast. So if you don't want to see the animation, you can directly run your simulation. But here we want to see the animation, so we just record it. Click on OK. So the simulation is running. So while running the simulation, we have enabled a Wireshark feature on node 1. So you can see the Wireshark has now started. And while running the simulation, we are having this Wireshark capturing the TCP packets in the network. So simulation is also running and the Wireshark is also functioning. Now we can minimize it and see our result. So simulation is over now. Now we can see these matrices that comes after the simulation. And this is your network matrix, where we are having simulation timing, packet transmitted, packet errored, packet collided, bytes transmitted, all this information of an overall network. Then we can have the overall throughput of our network, that is in application matrix. So here we have added two applications. One is custom from 1 to 9 and one is CBR from 2 to 4. So we can see that packet transmitted and received, this payload transmitted and throughput also. This is overall throughput. Then we add that. This is delay. Then we can have the link matrix where all the links are provided and their packet transmitted, error packets, collided packets, all the packets information of the link is there. So, and this is IP matrix of the devices 1 to 10. This is packet sent, packet received, packet forwarded, packet discarded, all this information in IP matrix. Then we can have the packet animation from here. So this is our network. Now we can play our animation. So we can see we have enabled the application from 1 to 9 and 2 to 4. So when it get the acknowledgement, it will send the packets. So in the green line, we can see that packets are moving from a different source and destination. And this is your detailed information of packets from source, destination, packet info, which packet is being sent, status, it is successfully sent or not, and this is simulation timing. Okay. So we can increase or decrease our size animation speed to see the animation faster. Okay. We can decrease the animation speed to see the animation in a slow manner, the simulation timing. Okay. Now we can stop the simulation and go for other features. So we have enabled the packet trace and event trace. So we can see the packet trace. So here we can see the overall packet information is there. So each and every packet which is being sent in our network, we have the details of that packet. So every packet, its packet information, packet ID, segment ID, packet type, control packet type, its source and destination, transmitter, receiver. So all the information regarding each and every packet is there. So you can analyze the packets while doing any research. So around 5,000 packets would be there. So we can have the details of each and every packet here in packet trace. Likewise, we can have the detail of events in event trace. So as the Netsim is a discrete event simulator, so all the events performing in the network will be provided here in event trace. So we can see all the event ID, event type, event timing, device ID, interface ID, all this information regarding the events will be there. Okay. Now we have also enabled the dynamic metrics where we can see the graphs of link throughput and application throughput. So this is the graphs for link, each and every link given in the network. Okay, and this is the graph for application throughput, custom and CBR application we have added. This is for TCP congestion window graph. Okay. So these matrices consist in a matrix.txt file. That matrix.txt file we also compare in a tool given here. We have to save this experiment first. Then we can go to the Netsim Analytics tool and we can list all the file So let's say we are having the matrix.txt file for one application. We are already having some matrix.txt file for internetworks only. So we just choose some of the files from here. So we are having 4 matrix file here. Now we can compare these matrix files. These are the matrix file which we have simulated the 4 different internetwork scenario for different parameters. So we can compare those matrices on these aspect of simulation timing: packet transmitted, packets errored, packets collided, bytes transmitted, payload transmitted, and overhead transmitted. Okay, so we can compare these matrices over these parameters. So now we have seen the GUI part where we can design and analyze our network. Now I'll show you the custom code implementation and how we can change anything in our existing protocol and how we can implement it in Netsim. So for that purpose, we have to go to the installation directory of Netsim, which is C program files and Netsim standard, where we are having the bin folder. In bin folder, all the protocols listed in the Netsim is given here with their DLL extension. So we can see all the protocols are given here in DLL extension. So when we call these functions, the DLL extension would be called in the Netsim, and they can interface with these DLL files. So now if you want to change anything in your existing protocol, that has to be saved in the DLL extension. So here there is an SRC folder where we have made a copy of this simulation. Then we have to open that netsim.sln file, netsim.solution file. So when we open this, it will open all your protocols listed in the Netsim in this Visual Studio environment. So you can see all the protocols are there. So we have opened an DSR protocol, which is having dsr.c file. So this is the program for dsr.c. Okay. So what we have made here is we have given a simple command of printing the hello world. So we are just implementing and see how it will reflect in our Netsim GUI. So we have just made a simple change. We have given a command for printing the hello world in the CLI mode. So we have to just edit it in the init function of DSR. And after the editing, you have to rebuild the file, right click and rebuild. So when you rebuild it, you will get your edited DLL in the DLL folder. So in the DLL folder, we are having the libdsr.dll. Okay. So this is your edited DLL now. So what you have to do is you have to copy this DLL and you have to paste in the bin folder of Netsim the same file. Okay. So before editing that file, we have made this original DLL as a libdsr default.dll. So this is our original DLL. Now we are copying our edited DLL. So that is libdsr.dll. This is our edited DLL now, and this is our default DLL. So we are just renaming it to save our original DLL file, and this is our edited DLL. Now we will call any DSR function and see how we can see the change in our environment. So we'll open a Vannet scenario. So these are the Vannet devices, wireless devices, where we are sending a CBR packet from 1 to 4. So we just have to ensure that DSR implementation is there. mobility model is also there. So we go to the network layer and see routing protocol DSR is implemented. Okay, so because we are calling the DSR function, we just have to accept it and run our simulation. So when we run our simulation, we can see in the CLI mode, hello world is printed. So as we have changed that in the dsr.c file to print hello world, so first it will print the hello world, then we put the enter, and it will say that detected a change in libdsr.dll. Press any key to continue. So if we continue, it will simulate your network further. So this is just to show you how we can change anything in our existing protocol and link it with Netsim to see the change. Okay, so further we can analyze other parameters. So this is about implementation of codes. Apart from this, we are having some programming exercises where we are having these protocols. So in with cryptography, you can see substitution, transportation. Let's say we are choosing the substitution, and this is the combination of programming and animation both. So we are having a sample programming running for encryption. So let's say we are entering a plain text with a key text of 3 and run the simulation. So it will convert it to the ciphertext. Then if we decrypt it, it will give you the plain text. So this is working according to a sample program running in it. That we can show also. And if you want to create your own code, you have to select the user and access that code. So we can see this interface source code in the Visual Studio. It will directly open in the Visual Studio if it is installed. So we can see the decryption code here. This is a default code. If you want to change anything in the protocol, it will reflect in the GUI. So that has to be saved in an exe extension, because if you select user from here to access your file, it will ask you an exe or zar file. So you have to browse that exe file saved and click on OK, and you can run your program through your code. So this is about this programming section, and this is for concept, algorithm and pseudo codes for study purpose. Apart from this, the help manual is provided, user manual, source code manual, and experimental manual. In experimental manual, we have provided around 22 experiments on different technologies. If you select any of the experiment, you can see its theoretical part, procedures, its input, how we can create a scenario, what are the parameters, okay, and what we have to analyze. The result is there. So this is the experimental manual. So I've done with my presentation. If you have any query, you can ask me by writing a question in the text box.